Hello, I belong to the Indian Institute of Science, and I am happy to share some of the knowledge and practices I have acquired over a long time. The Center Department of Electronic Systems Engineering was started at the ECE, and later on it was started as the Center for Electronic Design and Technology, where the concentration was on making physical, almost ready to produce industrial prototypes. So, in the beginning we were all concentrating on three aspects of a product. One of the aspects of the product is think about it from the top down approach, saying what is the final function of the this thing. So, for example, I have here a RF mic. So, it has 3 points very nicely how to do. One of them is the design of the circuit. We are especially in the what I call analytical point of view, circuit design has become relatively well understood, and if you give target specs, people can make a proper circuit. But physically when you want to realize it, suddenly we discover there are limitations. So, we need to design all the non-electrical parts surrounding it. That is how the whole concept of prototyping started. So, now at one time, if you can look at my slide presented here, you see here often somebody had to produce these parts which are generally made by, you have seen this, it is only made by injection molding. Now, the thing was such things were not possible to be made in by hand or with the available known resources. You see here we have beautiful industrial what you call looking prototypes. Now, this is where I feel your product I mean this particular course, it was a godsend that we now have what is loosely called 3D printing. Actually, this 3D printing issue is more related to how to make rapid prototyping, so that when production comes in place there are no surprises and we have the part exactly like that. And there is a special part here, this one is a holder for a Fresnel lens. So, this Fresnel lens holder has the advantage of having any radius we like, which we need to change frequently until we get the correct thing. What is not known too much about the rapid prototyping procedure is that while it looks easy to produce these parts, tremendous amount of design has to go into that. So, I will now go to this one or two small what you call prototypes. You see here product development process involves prototyping is done throughout the development process, in the concept development, system design, and so on like that. Down you see here this is Apple PowerBook. This did not come in one day, people were doing it by hand. Now, it is possible for us to happily do these things by using rapid prototyping. But the starting point of it is somebody has to imagine the product in its intended use. So, how these things come, and finally you see there is a little bit of CAD modeling, and this is done by SolidWorks by I mean we have all the things both from Siemens and these things. So, I just thought I will what you call help you along a little by showing you things from the what you call internet, also saying are there design rules. See here what looks like. See, we have a beautiful what you call design rules for 3D printing. This is available on the internet, there is no problem, but then a lot of it, rather tremendous amount of it still thinks about how to detail these things, and it is not as if all the time 3D printing is the same. So, we have several things like fused deposit modeling, stereolithography, selective laser sintering, material binding, and then what they call metal laser sintering and so on, by which complicated objects can be produced. So, using all these things in mind, Now, when you try to produce parts like this, often we end up with peculiarities which are different from the original thing, which are not easily realizable. So, my lecture, I would like to invite you all to have a look at these things, and I thought this is one of the things, this one, will you believe, it is a 9 to 5 clock, saying all of us just need to work smart from 9 to 5. And have you noticed something? The divisions between the hours are in quarters, meaning I have a quarter to something and a quarter past and so on, like that, saying now this whole thing, if you can think it, you can print it, and you are in, I can't say full business, you will not be making profit, at least you will have a thing to show somebody. Where it helps most is when you want to talk with your peers who are working with you in the group. Earlier it was almost over the wall design, like if you are an electronics engineer, you will try hard to make the best compact electronics, and then when you tell them, you see, I want something, this is called a cell phone, and it is very easy, it has 6 antennas, unbelievable, like that. No, nobody would have thought we could have packed in 6 antennas, and as if it is not sufficient, we also have a camera, then we have lighting, then we also have a camera here. Now, the latest ones have 2 cameras at the back. All this, while part of the electronics and all is reasonably understood, how to make an enclosure for it which is reliable is still part art, part practice, part science. And this is where I feel this rapid prototyping techniques on how to generate these parts and then how to present it to your colleagues who can now pack all the electronics into it, and finally we are in touch with the world. Wherever I am, I can call you back on various apps, and there are no missed connections anymore between the various facets of electronics product design. So, I will say welcome to the course, and the maximum people who are benefited are the ones who have some access to the technology, which somehow I do not know how to get the technology in the thing. You see here, all of them, actually these are the people in a way, I say this MakerBot are the people who started saying, you need not go anywhere, sit at home and do it. And you see here, we can, of course, there is a calibration device, it is not a copy thing, it is a scanner. If you have a part, you scan it, and then I can clone myself in it. So, we have all these beautiful pictures, and then anything we want, we can all be made to, we can make anything we like with it, but the core of it is just about the same. We have here all this printing head, and it is relatively easy, in fact to the extent that you can probably modify any XY table to make it into a 3D printer. So, this is the some students have been working on it, and it is not as if the technology is all original, this is old. This one is a something which prints negatives. Okay. So, we have all these beautiful devices and all that, and then I am sure all of you would have played with this car, except you see the chassis. That chassis is made with a acrylic sheet in which various slots are cut. This is very much possible for you, and the whole thing is assembled in parts. Right now it is very much possible for you to print the whole thing, and then even things like, I think you know what it is, it is taken from a old floppy drive, it is a aluminum casting. So, the thing is, the rules for them are not about the same. So, thank you, I feel you should join us, you will benefit if you have an access to a machine directly on your desktop. Alternatively, right now you can post your file to somebody via email or anything and the printed part comes back, and depending on how well you are connected, if you send it on Friday while you enjoy the Friday evening party dressing, Monday morning your job is delivered, it is on your table and you can play with it. So, small objects like this, I do not know what it is, right now it looks like just a stand, and then I have a pointer, and then I can use it for doing anything like that. I have some stylus here, then I have a switch here, whole thing somebody has conceived it, now it can be on your table. So, welcome to the lecture. I expect that with a little exposure from this course, and then after that when you go and try out your own thing, you will come out to be extremely useful. So, thank you.